All right, so welcome to our deep dive into the future of machine learning. In this deep dive, we're going to be looking at 18 brand new research papers that were published just today on rxeov.org. We're talking cutting-edge advancements in two main categories: computer science learning and computer science computer vision. And we're going to be doing more than just summarizing these papers. We're going to be extracting the so what, so why should you care?
Yeah.
You know, what are the real-world implications of all this, all these breakthroughs that are happening, and what might the future hold?
Yeah, I mean, it really is like panning for gold. We're sifting through all this research just to find those nuggets of knowledge that we think are going to shape the future.
Exactly. And one of the biggest nuggets I think we can all agree is that AI is getting smarter, but not only smarter, it's also getting faster too. Imagine an AI that could design its own experiments, could run them, and then learn from the results all by itself.
Well, you don't have to imagine it because that's actually the potential hinted at in a paper called Dolphin, Closed Loop Open-Ended Auto Research. And what's really amazing about Dolphin is that it's not just like crunching numbers. It actually reads research papers, generates ideas, writes the code to test those ideas, and then analyzes the results to improve future ideas.
It's like a tireless research assistant who never needs to sleep or eat.
Hmm.
So they tested Dolphin on some core tasks, things like 2D image classification and 3D point classification, and it's already showing some promising results.
And you think about what that means. I mean, this is a step towards AI actively participating in scientific discovery. I mean, not just as a tool, but as a collaborator, right? So think about the possibilities. I mean, think about drug discovery. AI could speed up research and lead to cures faster than we ever thought possible.
Yeah, I mean, it's mind-blowing the speed at which this is all developing. And speaking of speed, another paper that caught our attention is Breaking Through the Spike. And this paper focuses on making speech recognition lightning fast, right? I think we've all had that experience where, like, you talk to your voice assistant and there's that slight delay. Well, this research aims to eliminate that.
Yeah, the key here is it's something called spikes, which are characteristic patterns in speech recognition outputs. So by leveraging these spikes, the researchers developed a decoding method that's significantly faster, but doesn't sacrifice accuracy. So, I mean, this could revolutionize real-time translation or even how we interact with robots.
Right, and it seems like efficiency is becoming a really big focus, like across the board in AI research, which makes sense, right? I mean, we need AI that's not just powerful, but it's sustainable as well.
Absolutely. And there's a paper called The Race to Efficiency, a new perspective on AI scaling laws that really digs into this. And they argue that as AI models get bigger and more complex, the computational resources required to train them could become just astronomical, potentially taking millennia.
Millennia. I mean, that's longer than civilization has existed.
It is. So the takeaway is we need to prioritize efficiency, not just for speed, but for the future viability of AI development, right? We need algorithms and hardware that can keep up with our ambitions. And that means making things leaner and smarter.
So faster, more efficient AI. I mean, what does that mean for you and me?
Well, it could mean things like quicker drug discoveries that could lead to new cures. It could mean robots that could react in real time. It could mean near instantaneous language translation. I mean, it really is all about making our lives easier, making them safer, and making them more connected. But as AI gets more powerful, I think we need to think about how we collaborate with it and how we mitigate some of the potential misuse that could come along with that.
Right. I mean, because even the most advanced AI can make mistakes, right?
Absolutely.
So that potential for misuse is a real concern, especially as these systems become more and more sophisticated.
It is. And that's where a paper on the consideration of AI openness, can good intent be abused? Comes in. The researchers created data sets called EVE, which they used to fine-tune these large language models. And the results were pretty startling.
I mean, startling how? What happened?
Well, these fine-tuned models ended up giving bad advice on criminal activity, showing how even with good intentions, things can go wrong. It raises the question, how do we balance open access to AI research with the need to prevent its misuse?
It's a tough question, right? Because on the one hand, we want to encourage innovation, we want to encourage collaboration, but on the other hand, we need to be responsible. So finding that balance is going to be really crucial as AI continues to evolve.
Absolutely. It's not just about the technology itself. It's about the framework we build around it to ensure ethical and responsible development of AI. But speaking of collaboration, there are some positive examples of how humans and AI can work together effectively.
Oh, perfect. Let's dive into one of those examples.
Okay, so there's a paper titled Socratic Questioning, Learn to Self-Guide Multimodal Reasoning in the Wild. And they introduce an AI system that learns by asking itself questions. Think of it like a detective constantly asking clarifying questions to get a clearer picture of a case.
So the AI is like basically interrogating itself
Yeah.
to improve its understanding.
Yeah, that's exactly it. They tested this system on a new data set called CapQA, which focuses on visual reasoning. And it showed significant improvements in reducing something called hallucinations, which is basically when AI makes up information that isn't really there.
That's a big deal, right?
Yeah.
Especially as AI systems become more and more integrated into our lives. We don't want them making stuff up.
We don't. And this really points to a future where AI not only just recognizes objects or patterns, but it understands the relationships between them. So this deeper level of understanding could lead to systems that are more intuitive, more helpful, maybe robots that can truly understand our needs and provide assistance in a much more sophisticated way.
So, I mean, it sounds like we're moving towards AI that can actually reason and think more like humans. It's exciting, but also a little bit intimidating, don't you think?
I mean, it definitely raises a lot of questions about what it means to be intelligent and how we define consciousness, but that's a conversation maybe for another deep dive.
Yeah, another day, right? For now, I think we should stick to exploring those amazing things that AI is already capable of doing.
Sounds good to me. Should we shift gears a little bit and talk about how AI is pushing the boundaries of what's possible, specifically in healthcare?
Yeah, let's hear it. What kind of medical breakthroughs are we talking about here?
So one paper that really caught my eye is called Detecting Neurocognitive Disorders. And this research uses AI to analyze how people tell stories, looking for those subtle signs of cognitive decline, even in the very early stages.
Wait, so AI can like detect Alzheimer's just by like listening to someone talk? How does that even work?
Well, it's not just about listening to the words, it's about analyzing the structure and coherence of the narrative over time, right? So the AI looks at things like topic transitions and consistency, picking up on those subtle differences that a human listener might miss.
I mean, that's incredibly subtle. And early detection is obviously key for diseases like Alzheimer's. So if AI can actually help with that, it could have a huge impact on, treatment and care.
It absolutely could. Early intervention could potentially slow the progression of the disease and, significantly improve the quality of life for patients.
That's a remarkable application of AI. What else is happening in the world of AI and healthcare?
Well, there's another interesting paper called License Plate Images Generation with Diffusion Models, and it tackles a slightly different challenge, training AI systems to recognize license plates. You might think, well, that's not a big issue, but it turns out that real license plate data sets are really hard to come by due to privacy concerns.
Right, yeah. So how do they even train the AI if they don't have enough real-world data?
Well, that's where this research gets really innovative. They use AI to actually create synthetic license plate images that are completely made up,
Yeah.
but incredibly realistic. So these synthetic images can then be used to train the recognition systems without any privacy issues.
It's a clever workaround, and I imagine accurate license plate recognition could have implications beyond just, like traffic enforcement, right?
Yeah, absolutely. I mean, think about security applications, parking management, even self-driving cars. This technology could make our cities safer and more efficient.
It's amazing how AI can solve problems that we might not even think about.
It's the beauty of it, constantly evolving, finding new ways to improve our lives.
So we've covered AI that can design experiments, AI that can detect diseases, AI that can create fake license plates, all in the name of progress. What else is out there?
Well, there's a lot of research focused on making AI systems more efficient and more robust. One paper in particular, information maximized soft variable discretization for self-supervised image representation learning, introduces a new method for improving how AI learns from images.
I mean, image recognition is already pretty advanced. How much better can it get?
You'd be surprised. This new method, it's called IMSVD, helps AI extract more meaningful information from images, so it reduces redundancy and improves performance on tasks tasks like object detection. Think of things like self-driving cars or medical imaging, where accuracy is absolutely critical.
So it's not just about recognizing what's in the image. It's about like actually understanding it on a deeper level.
Exactly. And the more AI understands, the more effectively it can interact with the world around us.
Makes sense. It seems like every new development in AI kind of builds on the last one, like pushing the boundaries further and further. So what else have you got for us?
Well, speaking of pushing boundaries, let's talk about face recognition. It's a very powerful technology, but it's also susceptible to things like compression artifacts, which can distort facial features and lead to errors.
Yeah, I've seen those like blurry, pixelated images.
Yeah.
It's hard to imagine how AI could accurately recognize someone from that.
It is. And that's where this paper, Deep Learning-Based Compression Detection for Explainable Face Image Quality Assessment, comes in. And it uses deep learning to detect those compression artifacts and assess the overall quality of facial images.
So it's like having an AI quality control expert for face recognition.
That's a great way to put it. And this could significantly improve the reliability of facial recognition systems, from security applications to, even personal photo albums.
Okay, so we've got AI that can create images, AI that can analyze images, now AI that can judge the quality of images. It's pretty impressive how versatile this technology is.
It is. It's a testament to the ingenuity of these researchers who are constantly pushing the limits of what AI can do.
And speaking of pushing limits, what about like adapting existing AI models to new and challenging environments? I imagine that's got to be a significant hurdle.
It is. I mean, think about vision language models. So those are AI systems that understand both images and text. So they're used for things like image captioning, visual question answering. But what happens when they encounter real-world scenarios that are different from the data they were trained on?
I mean, I guess they wouldn't perform as well. It's like trying to speak a foreign language that you only learn from a textbook, right? You might struggle in a real conversation.
That's a great analogy, and that's exactly the problem that this paper, Realistic Test Time Adaptation of Vision Language Models, addresses. They introduce a method called STATA, which helps these models adapt to new data without forgetting their initial knowledge.
So it's like giving these AI models like a crash course in the new environment without erasing everything they already know.
Exactly, and this could lead to more robust and reliable AI systems that can function effectively in a wider range of applications. So think about assistive technologies for people with visual impairments. The AI needs to be able to adapt to different environments, lighting conditions
Right.
seamlessly.
I mean, that's a really powerful application. It's amazing how AI can be used to improve accessibility and really empower people with disabilities.
It is, and it's just one example of how AI is being used to address real-world challenges and improve lives. Shall we explore another fascinating application?
Definitely. What else have you found?
Okay, let's dive into the world of remote sensing. So this plays a crucial role in monitoring our planet, talking about tracking weather patterns, managing natural resources, responding to disasters.
Yeah, I mean, it's amazing how much we rely on remote sensing data.
Right.
But I imagine analyzing all that data can be incredibly time-consuming and complex.
It can be, and that's where AI comes in. The paper, Strip RCNN, Large Strip Convolution for Remote Sensing Object Detection, introduces a new method for detecting objects in aerial images. It's particularly effective at identifying objects with high aspect ratios, things like ships or airplanes.
So instead of manually combing through like hours of footage, AI can pinpoint those objects of interest quickly and accurately.
That's right, and this could have really significant implications for environmental monitoring, disaster response, even urban planning.
It's incredible how AI can help us better understand and manage our planet, really.
It truly is. And speaking of understanding, let's talk about anomaly detection. So it's a critical task in everything from cybersecurity to medical diagnosis.
Anomaly detection, what exactly is that?
So it's all about identifying those data points that deviate from the norm. So this could indicate a problem or an unusual event. Think of it like a smoke detector for your data. It alerts you when something seems off.
It's a great analogy. So How is AI being used for anomaly detection?
So the paper, CanoClip, zero-shot anomaly detection through knowledge-driven prompt learning and enhanced cross-modal integration, introduces a new method that leverages the power of vision language models.
Vision language models, again, it seems like they're popping up everywhere.
They really are, and for good reason. They're incredibly versatile. So this particular method, it's called CanoFluPit, can detect anomalies in data it's never seen before, which is a big deal.
But how's that possible? Doesn't AI need to be trained on like examples of anomalies to be able to recognize them?
Traditionally, yes, but this method uses something called knowledge-driven prompt learning, which basically means it leverages existing knowledge from language models and visual question answering systems to create prompts that guide the anomaly detection process.
So it's like giving the AI a set of rules to follow, even if it hasn't encountered specific anomalies before.
Yeah, that's a good way to put it. And this approach has proven to be incredibly effective, achieving state-of-the-art performance in zero-shot anomaly detection.
It's amazing how AI can learn and adapt without needing those massive amounts of training data.
It's a testament to the power of knowledge representation and transfer learning. Shall we explore another cutting-edge application?
Absolutely. What else is on the agenda?
Okay, so let's talk about face morphing attack detection, or MA. So this is all about protecting facial recognition systems from attacks where someone creates a morphed image that can fool the system into thinking it's a real person.
I mean, that sounds like something straight out of a spy movie.
Yeah.
But I guess in today's world, it's a real threat.
It is. And the paper, Manzation Face Morphing Attack Detection with Foundation Models, dives deep into this issue. And it explores how to leverage foundation models, which are these large language models trained on massive data sets
So these are the same kinds of models that are powering things like chatbots and text generation tools, right?
That's right. But in this case, they're being used to analyze facial images and detect signs of morphing. The researchers found that their framework, which they called medation, outperforms other methods, even surpassing some of the best existing MIDI solutions.
So it's reassuring to know that researchers are actively working to counter these threats and make facial recognition systems more secure.
It's an ongoing battle, but AI is playing a crucial role in both defense and offense.
Okay, so we've covered AI that can detect anomalies, AI that can protect against face morphing attacks, and AI that can generate synthetic data. And it seems like there's no limit to what this technology can do.
It's truly remarkable, and there's even more to explore. Shall we delve into the world of LiDAR data?
LiDAR, isn't that the technology used in self-driving cars?
That's right. So LiDAR sensors provide that 3D information about the environment, which is essential for autonomous navigation. And the paper, LIMO, Mixture of LiDAR Representation Learners from Automotive Scenes, introduces a new framework for learning from LiDAR data.
So it's about making self-driving cars even better at perceiving and understanding their surroundings.
Precisely. So this framework, called LIMO, can learn from different LiDAR representations, so things like range images, sparse voxels, raw points, and combine them to create a more comprehensive and accurate representation of the environment.
I mean, that sounds like a big step towards making self-driving cars safer and more reliable.
It is, and it's another example of how AI is being used to push the boundaries of autonomous systems.
All right, so far in this first part of our deep dive, we've gone from AI-powered scientific discovery to the ethical considerations of these really powerful AI systems, and we've only just scratched the surface.
Yeah, we still have a lot more fascinating research to uncover, so make sure to tune in for part 2, where we'll continue our exploration of the cutting edge of machine learning.
We'll be back soon with more mind-blowing insights. Welcome back to our deep dive into the latest machine learning research.
Yeah, we're going to pick up right where we left off, exploring all the incredible ways that AI is being used to tackle some of those complex challenges in medical imaging.
I mean, it's amazing how AI is revolutionizing healthcare, from diagnostics to treatment planning. It seems like there's no area of medicine that isn't being impacted.
You're right. And one area that's seeing some particularly exciting advancements is MRI reconstruction. Imagine getting these clearer, higher resolution MRI images in a fraction of the time.
Oh, that would be a game changer for both patients and clinicians. I mean, faster scans means less time in those, sometimes claustrophobic machines, and quicker diagnoses.
Exactly, and that's precisely what a paper titled "A Self-Supervised Diffusion Bridge for MRI Reconstruction" is all about. They propose a new method for reconstructing those MRI images using a technique called diffusion bridge. Now, you might have heard about diffusion models in the context of like image generation, but here they're being used to improve the speed and quality of MRI scans.
So instead of generating like brand new images, they're kind of like enhancing existing ones.
Precisely. And what makes this research particularly interesting is that it uses a self-supervised approach. So traditional diffusion bridge methods require these high-quality reference images for training, which can be difficult and expensive to obtain. But this new method called self-DB eliminates that need.
So how does it learn if it doesn't have those reference images?
Well, that's the ingenious part. Self-DB learns directly from the noisy MRI measurements themselves. It's like teaching the AI to denoise the images by learning the patterns of degradation and then reversing them.
So it's like having an AI noise canceling system for MRI images.
That's a great way to think about it. This could lead to faster MRI scans with higher resolution, potentially revolutionizing how we diagnose and treat a wide range of conditions.
It's incredible to see how AI is pushing the boundaries of medical imaging. Are there any other breakthroughs in MRI research that caught your eye?
Absolutely. Another paper titled FGC2FUDIF. Frequency-guided and course-defined unified diffusion model for multimodality missing MRI synthesis takes this whole concept of AI-powered image enhancement even further. It addresses a common problem in medical imaging, missing modalities.
Missing modalities. What exactly does that mean?
So sometimes due to, various limitations, certain types of MRI scans might not be available for a patient. This could be due to costs, time constraints, or even the patient's medical condition.
So it's like having a puzzle with missing pieces, which makes it harder to see that complete picture.
Precisely, and this paper proposes a method for synthesizing those missing MRI modalities using a unified diffusion model. It combines frequency information with a course-defined denoising process to generate highly realistic and accurate synthetic images.
So even if a patient can't undergo a specific type of MRI scan, AI could potentially fill in the gaps.
Exactly. It's like having an AI artist that can paint in the missing details based on the existing information. This could provide clinicians with a more complete picture for diagnosis and treatment, potentially leading to better outcomes for patients.
It's amazing how AI is being used to overcome these limitations in healthcare. It's like giving doctors a superpower.
It really is transforming the field. Now let's shift gears a bit and talk about how AI is improving the speed and accuracy of ultrasound imaging.
Ultrasound is such a vital tool in medicine, but I know it can sometimes involve those trade-offs between speed and resolution.
Right. And the paper Revisible Dual Domain Self-Supervised Deep Unfolding Network for MRI Reconstruction tackles this challenge head on, proposes a new method for reconstructing high-quality ultrasound images from undersampled data.
Undersampled data. Does that mean they're working with incomplete information?
Exactly, and this can lead to information loss and blurry images. So they address this by using a dual-domain self-supervised approach, which essentially means that they're leveraging all the available data to its fullest potential.
So it's like squeezing every last drop of information out of the data.
Yeah, that's a great analogy. They also incorporate imaging physics and image priors into their deep unfolding network, which helps guide the reconstruction process and improve accuracy.
It sounds like they're combining the power of AI with a deep understanding of how ultrasound imaging works.
Precisely, and this could lead to faster and more accurate ultrasound imaging, particularly beneficial for real-time applications like guiding surgical procedures.
It's incredible to think that AI could be assisting surgeons in real time, making surgeries safer and more precise.
It's a truly exciting prospect. Now, another paper that caught my attention in this area is Deep Sylvester Posterior Inference for Adaptive Compressed Sensing in Ultrasound Imaging.
Okay, this one sounds intriguing. What's the focus here?
Well, this research focuses on a technique called adaptive subsampling, which essentially means reducing the number of scan lines required in ultrasound imaging.
So fewer scan lines means faster imaging.
Exactly, but the challenge is to reduce the number of scan lines without sacrificing image quality. And that's where this research gets really clever. They developed a method that uses a deep generative model to predict future observations, and a Sylvester normalizing flow encoder to infer an approximate Bayesian posterior.
Okay, that sounds pretty complex. Can you break it down for us a bit?
Sure. Essentially, they're using AI to figure out which scan lines are the most informative,
Mhm.
and then focusing on acquiring those, maximizing information gain while minimizing acquisition time.
So it's like AI is helping the ultrasound machine decide where to look.
That's a great way to put it. They tested their approach on a cardiac ultrasound video dataset, and they found that it significantly outperforms other subsampling methods, reducing reconstruction error by an impressive 15%.
That's a significant improvement. What's even more impressive is that this whole process takes just a fraction of a second, making it suitable for real-time applications.
It's incredible how AI is making ultrasound imaging faster, more efficient, and more accurate. It's really a testament to the power of combining those cutting-edge AI techniques with a deep understanding of the underlying physics and principles of medical imaging.
Now, but before we move on from the world of healthcare, I'm curious to hear about any research that's using AI to gain insights into the human brain.
Oh, there's definitely some fascinating work happening in that area. One paper that really stood out to me is detecting neurocognitive disorders through analyses of topic evolution and cross-modal consistency in visual stimulated narratives.
Oh, wow. That title is a mouthful. Can you give us the layman's terms version?
Sure. This research explores how AI can analyze the way people tell stories to detect early signs of neurocognitive disorders, things like Alzheimer's disease.
So instead of relying on like those traditional cognitive tests, they're using storytelling as a diagnostic tool.
Precisely. And what makes this approach unique is that it goes beyond just analyzing the words people use. It analyzes the overall structure and coherence of the narrative, looking for those subtle changes in topic transitions and consistency over time.
So it's not just what they're saying, but how they're saying it.
Exactly. The researchers found that these macrostructural features are actually more effective than traditional microstructural features for detecting cognitive decline.
It's like AI is listening for those subtle shifts in the way someone's thoughts flow.
That's a great way to put it. They developed two different approaches for analyzing narratives. One based on dynamic topic models,
Mhm.
and another using a text-image temporal alignment network. And both approaches achieved some impressive results, demonstrating the potential of AI to identify cognitive impairments through subtle changes in storytelling.
That's incredible. It could open up entirely new avenues for early diagnosis and intervention, potentially leading to better outcomes for patients with neurocognitive disorders.
It's a powerful example of how AI can be used to understand the human mind
Yeah.
and potentially improve cognitive health.
Before we wrap up this part of our deep dive, I'm curious to hear about any research that focuses on improving the performance of machine learning models themselves. It seems like there's always a push to make these models more efficient and accurate.
Yeah, you're absolutely right. And there are a couple of papers in this batch that caught my eye in that regard. One is data augmentation for deep learning regression tasks by machine learning models. This research explores how to use machine learning models themselves to generate augmented data.
Wait a minute. Using AI to create more data for AI, that's like a snake eating its own tail.
It might sound strange, but it's actually a very effective technique. So data augmentation is all about increasing the size and diversity of a training data set, which can significantly improve the performance of machine learning models.
So instead of relying solely on real world data, which can be limited, they're using AI to create synthetic data that kind of mimics the real thing.
Precisely. And this paper shows that this approach can significantly improve the performance of deep learning models on regression tasks involving tabular data.
So it's like giving those models extra practice
Mm.
so they can perform better in the real world.
Yeah, that's a great way to think about it. Now, another paper that caught my attention is towards mitigating architecture overfitting on distilled data sets. And this one focuses on knowledge distillation, which is a technique for transferring knowledge from a larger, more complex model to a smaller, more efficient one.
So it's like taking all the wisdom from a seasoned expert and passing it down to a younger apprentice.
That's a perfect analogy. Knowledge distillation is all about creating these smaller, faster models without sacrificing accuracy. But sometimes those distilled models can suffer from something called architecture overfitting, which basically means they're too tailored to the specific architecture they were trained on.
So they're kind of like one-trick ponies, right? They can do one thing really well,
Right.
but they struggle to adapt to new situations.
Exactly, and this paper introduces a series of approaches for mitigating this problem. They use techniques like drop path and knowledge distillation itself to improve the generalization ability of models trained on distilled data, making them more robust and more reliable.
So they're essentially making those distilled models more well-rounded and adaptable.
That's the goal. It's all about pushing the boundaries of what's possible with machine learning, making models more efficient, more accurate, more reliable, so they can be deployed in a wider range of real world applications.
It's exciting to see how researchers are constantly innovating and finding new ways to improve these models. It's like watching the evolution of AI in real time.
It truly is, and this constant evolution is what makes the field of machine learning so dynamic and so fascinating. There's always something new to discover, some new breakthrough just around the corner.
Well, we've certainly uncovered a wealth of discoveries in this part of our deep dive. We've explored how AI is revolutionizing medical imaging, gaining insights into the human brain, and even improving its own performance.
And we've only just scratched the surface. There's still so much more to explore, so make sure to join us for the final part of our deep dive, where we'll delve into even more fascinating advancements in AI and discuss their potential impact on our lives.
We'll be back soon with more mind-blowing insights.
Yeah.
Welcome back to the final part of our deep dive into the cutting edge of machine learning.
Yeah, it's been an incredible journey so far, exploring, everything from AI-powered medical breakthroughs to the potential of AI in scientific discovery.
We've seen how AI is not just changing the world around us, but also pushing those very boundaries of what we thought was possible.
And in this final part, we're going to dive into even more groundbreaking research, uncovering those latest advancements and discussing their potential impact on our lives.
Sounds exciting. So what's first on the agenda?
Well, let's start by exploring the intersection of AI and cybersecurity, a field where those stakes are incredibly high.
Yeah, I mean, cybersecurity is more important than ever these days, with so much of our lives happening online. Protecting our data and systems is crucial.
Absolutely. And the paper Machine Learning-Based Security Policy Analysis dives deep into this world, focusing on a powerful security mechanism used in many Linux systems called Linux.
Linux. That sounds familiar. Isn't it a way to control access to different parts of a computer system?
Yeah, you got it. It's like having a security guard for your operating system,
Right.
making sure that only authorized users and processes can access those sensitive data and resources. But the policies that govern Linux can be quite complex and difficult to analyze manually.
Yeah, I can imagine. It's like trying to decipher a secret code.
That's a great analogy, and that's where this research comes in. They propose using a combination of graph-based techniques and machine learning to automate Linux policy analysis.
So instead of security experts, spending hours poring over these policies, AI can kind of do the heavy lifting.
Exactly. So they represent those policies as graphs, which are those visual representations of how different parts of the system are connected. Then they use a technique called Node2Vec to transform those graphs into numerical representations that can be fed into those machine learning models.
So it's like translating those complex security policies into a language that AI can understand.
That's a great way to put it. And those machine learning models can then be used to detect anomalies and potential vulnerabilities in the policies, providing valuable insights for security administrators.
It's like having an AI security consultant constantly scanning for weaknesses and recommending improvements.
Precisely. And the researchers found that a type of neural network called a multi-layer perceptron, or MLP, achieved the best results with an impressive 95% accuracy in detecting policy violations.
I mean, that's incredibly accurate. It seems like AI could be a real game changer for cybersecurity, helping us stay ahead of that ever-evolving threat landscape.
It's certainly a powerful tool in our arsenal. Now, let's shift our focus to a paper that examines the challenges and opportunities of scaling AI model.
Yeah.
We've talked a lot about how AI is, becoming more powerful, but what are the implications of that growth?
Yeah, that's a great question. I mean, more powerful AI sounds great, but what about the resources required to develop and train these increasingly complex models?
That's a crucial consideration, and the paper, The Race to Efficiency, a new perspective on AI scaling laws, really digs into this issue. They argue that as AI models get bigger and more complex, those computational resources required to train them could become astronomical.
Yeah, we touched on this earlier, talking about training times potentially stretching into millennia, which I mean is not exactly sustainable.
Exactly, and this paper introduces a new framework that takes into account both time and efficiency, highlighting the need for a race to efficiency to sustain the progress of AI.
So it's not just about making AI more powerful; it's about making it uh, more efficient as well.
Precisely. The researchers argue that we need to focus on developing those more efficient algorithms, hardware, and training techniques to keep pace with those growing demands of AI.
So it's like we're trying to build a rocket that can reach the stars, but we also need to make sure it's fuel efficient.
That's a great analogy. If we can achieve those efficiency gains at a rate comparable to Moore's law, we can continue to push those boundaries of AI without requiring those unsustainable amounts of computational power.
It's a fascinating challenge, and it really highlights the importance of collaboration between researchers and AI, hardware, and software development.
Absolutely. It's a team effort, and we need to work together to ensure that responsible and sustainable development of AI. Now, let's shift gears again and dive into a paper that explores a new approach to learning stochastic nonlinear dynamics.
Stochastic nonlinear dynamics.
Or
That sounds pretty complex. Can you give us a quick primer?
Sure. So stochastic nonlinear dynamical systems are basically systems that evolve over time in a way that's both random and nonlinear.
Nonlinear meaning not a straight line.
Exactly. These systems are found in various fields, from climate modeling to financial markets, and understanding their behavior is crucial for making those predictions and decisions.
So how does this research help us better understand these complex systems?
Well, the paper, Learning Stochastic Nonlinear Dynamics with Embedded Latent Transfer Operators, introduces a spectral method for learning these systems. Use a technique called embedded latent transfer operators. It's a mouthful, but essentially it involves embedding that system's state in a high-dimensional space, and then using a transfer operator to describe how that state evolves over time.
So it's like creating a map of the system's possible states,
Hmm.
and then tracking how it moves through that map.
That's a great way to visualize it, and this approach allows researchers to model that system's dynamics more accurately and more efficiently, even when dealing with highly nonlinear and noisy data.
And what are the practical implications of this research?
Well, this method can be used for tasks like sequential state estimation and mode decomposition,
Yeah.
which are essential for understanding and predicting the behavior of these systems.
So, for example, it could help us better predict weather patterns or understand the fluctuations of the stock market.
Precisely. It's a powerful tool for anyone trying to make sense of those complex systems that evolve over time. Now, before we wrap up our deep dive, I want to highlight a few papers that showcase the incredible diversity of AI applications.
Yeah, sounds good to me. I'm always amazed by the sheer range of problems that AI is being used to solve.
One paper that caught my eye is multimodal machine learning can predict video conference fluidity and enjoyment. This research explores how AI can analyze those video conference interactions and predict moments of negative experience.
Just like having an AI meeting moderator,
Mhm.
making sure everyone's engaged and happy.
That's a great way to put it. They use multimodal machine learning, combining audio, facial expressions, and body language to identify those instances of low conversational fluidity and enjoyment.
It's amazing how much information AI can uh, glean from those subtle cues like facial expressions and body language.
It's a testament to the power of multimodal learning.
Yeah.
And this technology could be used to improve the design and user experience of those video conferencing
Mm.
platforms, making those virtual interactions more natural and more engaging.
Yeah, that's definitely something I could use during those long Zoom meetings. What other applications have you found?
Well, another interesting paper is deploying open source large language models, a performance analysis. This research investigates the practical challenges of deploying those open source large language models, which have become increasingly popular in recent years.
Yeah, open source models are great because they make AI more accessible to everyone. But I imagine deploying those massive models can be a logistical nightmare.
It definitely presents challenges. So this research analyzes the performance of different models on various hardware configurations, providing those valuable insights for organizations looking to deploy these powerful AI systems.
So it's like a guidebook for anyone wanting to harness that power of open source large language models.
Exactly. It's a valuable contribution to the democratization of AI, making it easier for more people and organizations to access and utilize these cutting-edge technologies.
Well, that brings us to the end of our deep dive into the latest machine learning research. It's been an incredible journey exploring that vast landscape of AI advancements.
We've covered a lot of ground from AI's growing role in cybersecurity and scientific discovery to its impact on healthcare and everyday life.
It's clear that AI is rapidly advancing, pushing those boundaries of what's possible and transforming the world around us.
But as with any powerful technology, it's crucial that we approach AI development and deployment with careful consideration, ensuring that it's used responsibly and ethically.
I mean, we've seen both the incredible potential of AI and the potential risks, and it's really up to all of us to shape the future of this technology.
We need to engage in those thoughtful conversations, foster collaboration between researchers, policymakers, and the public, and prioritize the development of AI systems that benefit all of humanity.
And we hope this deep dive has given you a glimpse into the exciting and rapidly evolving world of machine learning and inspired you to learn more about how AI is shaping the future.
Remember, AI is a tool, and it's up to us to wield it wisely. Thank you for joining us on this incredible journey, and until next time, keep exploring the frontiers of knowledge.